Okay, for Chapter 2, Section 3, we're going to look at limit laws. So let's take a look. So for the first one, they just want you to plug in the values. So it says the limit of the function f of x plus g of x for g of x. So it turns out if you have the limit of two functions being added, you can break those up into the limit as x approaches 3 of f of x plus, and I can pull out this 4, so that 4 can come out, and we can call this the limit as x approaches 3 of g of x. So you can split those up. And it says that the limit as x approaches 3 of f of x is just 1. So this whole thing goes to 1. And it says the limit as x goes to 3 of g of x is negative 2. So this whole thing goes to negative 2. So the whole thing simplifies to simply 1 plus 4 times negative 2, which is 1 minus 8, which is minus 7. And that's what we have here. Okay, very similarly, they have the limit of x going to 3 of g of x, and they cubed g of x, but you can actually cube the entire thing. So this becomes the limit of g of x as x goes to 3 is just negative 2, and that's going to be negative 8. Same idea for c. We can take the square root of not just the f of x, but the entire limit. And it said that the limit as x goes to 3 of f of x was 1. So this is the square root of 1, which is just 1. D, we have the limit of two things being divided. Well, you can apply this limit to top and bottom, and I can pull the 4 out like I did before. And the top is the whole limit of f of x as x goes to 3 was 1, so this is 4 times 1. And the limit of g of x was negative 2. I guess I shouldn't have capitalized that. There we go. And so we get 4 over negative 2, which is negative 2. Okay, for E, I could have written it E. I can split it up again, g of x, limit x approaches 3 of h of x. The top is negative 2, but the bottom, the limit of h of x as x approaches 3 stated in the problem statement is 0. So this one, you can't divide by 0, so we're going to say this does not exist. Undefined, not exist, something like that. Okay. Last one, we have the limit as x approaches 3 of g of x times the limit as x approaches 3 of h of x divided by the limit. So notice I'm applying the limit to each of these terms here as x approaches 3 of f of x. And I might also say that this only works because the limit, all these limits are defined for the same number, 3, 3, and 3. So they're all approaching 3. If they're approaching different numbers, you have to be very careful about doing what I'm doing. Okay, g of x, that whole thing simplifies to minus 2. H of x simplifies to 0, and f of x simplifies to 1. This would be 0 over 1. Now you can divide into 0. That's just 0. So we're going to get 0 for that one. Okay, and that's problem 1. Okay, for problem 2, they give us a graph. A lot of times these are a little simpler. And so it says the limit as, and I'm not going to break these up anymore. Basically, we can just say, okay, what is the limit as f of x approaches 2? What is the limit as of g of x as x approaches 2? Let's just write those numbers in, and then we don't have to write so much. Okay, so f of x is this left curve, and I'm approaching 2. 2 is right here in the x. So again, you have to kind of make your brain think in different terms. This number here is left or right. I'm just moving left or right to get to the number. The actual function is going to go up or down. It's the up or down number that we're trying to record as we get close to 2. So as I approach 2 from either side, the function is going towards this hole, which occurs at -1. So this whole thing is going to be -1. Okay, then g of x. Okay, for g of x, it also is approaching 2. So here's 2. From the left, I'm approaching that corner. From the right, I'm approaching that corner. That corner occurs at +2. So this would simplify to +2. So this whole thing would become -1 plus 2, which is 1. Okay, have to do a bunch of these. Okay, for the next one, it says f of x minus g of x, but now we're approaching 0. So we're approaching this 0 point. From the left, we're approaching there. From the right, we're approaching there. That point is 2 units in the y. So this would be 2. G of x, we're approaching 0. From the left, it's approaching 1, 2, 3. From the right, it's approaching 1. Since these are approaching 2 different numbers, this limit itself does not exist. So f was okay, it approached one single number, but g, as I'm going towards 0, left or right, one side's approaching +3, one side's approaching 1. Those are 2 different numbers, so we'd say the whole limit does not exist. Okay, for c, we're approaching -1, so we want to get to this line right here. And for f of x, as I approach from the left and I approach from the right, they are both approaching +1. So this f of x is going to be 1. G of x, we're approaching -1 right here. It's approaching from both sides the same value, which is +2. So this is going to be 2. So this equals 1 times 2, which is just 2. Okay. Let's look at the next one. We're approaching 3. So 1, 2, 3, that's this line here. F of x from the left is approaching this point, and from the right it's also approaching that point. Well, that has a y value of 1. So this is going to be 1. G, we're approaching 3, 1, 2, 3 right here. It's approaching this point from the left, this point from the right. That point is 0. So we have a problem there. We're dividing by 0. So this would be does not exist. Okay, for the next one, it's just f of x, there's no g of x, and we're approaching 2. So 2 is here. We already saw this one, left and right. They're both approaching -1. So f of x is -1. But there's an x squared in there. So to cover x squared, we're just going to plug x is 2 into that. So this is going to equal 2 squared times f of x, which is -1. 2 squared is 4. And so we get -4. Okay, last one. We have just g of x, and we're approaching -1. We're approaching from the left, we're approaching from the right. It's the same number, which is 2. Oh, I missed one here. So this is 2, and they want f of -1. So that's a little different. F of -1 says let x equal -1, which is right here. and then go up till you get to the graph. So if you go up, the first thing you see is a hole, so you're going to skip past that. And you're going to go to where there's a filled in dot right up there, and that has a y value of 1, 2, 3. So this value is 3, plus this value is 2, so we get 3 plus 2, which is 5. Okay, and that'd be problem 2. Okay, for problem 3, they give us a limit, and it says the limit as x approaches 8 of 2 different bubbles. Well, all you have to do is plug in 8 for all these x's. So and the limit will go away. So you're going to get 2 plus the cube root of 8 times 2 minus 6 times 8 squared plus 8 cubed. And the cube root of 8 is 2. And if you do this, you're going to get 130 after you do the math on this one. So you get 4 times 130, which is 520. Okay, so just substitute the number for the x values. Okay, so problem 4. So one of the things about limits is whenever you get a limit, especially of a fraction and you have like a polynomial on top and a polynomial on bottom, what you want to try to do is see if it will simplify. So let me write it a little bigger. X squared plus x minus 12 divided by x minus 3, and they're saying that equals x plus 4. Well, let's test that. You can factor x squared plus x minus 12 as x plus 4 x minus 3. In the bottom, I'll add parentheses just so it's easier to see, is x minus 3. So you can delete, you can cross these off, but before you do that, you have to record x should not equal 3. X can't equal positive 3 because if it did, the denominator would become 3 minus 3, which is 0, and you'd have a divide by 0 error. So it does simplify to just x plus 4, as it's stated up here, once you cancel those two, but you have to record that you should not let x equal 3. So the best way to say it is the left-hand side is not defined for x equal 3, but the right-hand side is. So that's why they're not equivalent statements. Okay, let's see. For the next one, I don't think I need to show anything here. So it's the same equation. It's going to factor into the same way, but now they added a limit on the right side. So these two will be equivalent because the equation holds for all x not equal to 3. It follows that both sides of the equation approach the same limit as x approaches 3. So if you plug 3 in here, you get 7. So this whole thing equals 7. So if we were to plot this curve, and I won't just for the sake of time, you would see as x approaches 3 that it does converge towards 7. So they approach the same number. So their limits are equivalent. Problem 4. Okay, for problem 5, 6, and 7, you're just going to plug in the x value they give you. For the most part, like I can't plug in x equal 3 right away here because if I did, I'd get 0 in the denominator. But we already saw this one. No, we didn't quite see this one. Let's do this one. This one will simplify. The top can factor into x. Let's see here, x minus 3, x minus 1. So the second two terms should multiply to positive 3, and then the middle terms should add to minus 4, and they do. And then we had an x minus 3 on the bottom. So we're going to cancel those two. But I will say if we're writing a domain problem, we would say, hey, don't let x equal 3. So we're going to restrict that. But the whole limit simplifies nicely to just the limit as x approaches 3 of x minus 1. And now there's no issue. I can just plug 3 in, and we'll get 3 minus 1, which is 2. So the limit should just be 2. Okay, problem 6 is a little more involved because you have something to the third power. So you have the limit as h approaches 0 of 3 plus h cubed. Now I'm going to write this out. 3 plus h, 3 plus h. Then you have minus 27. All divided by h. Now we're gonna have to FOIL this. So first 9, outer 3h, inner 3h, last h times h squared. But that's also being multiplied by a 3 plus h. And then the minus 27 is out there. So now we got to do another round. So we have to do 9 times 3, which is 27. I didn't write it. I should write it. This is still the limit as h approaches 0. So there's still a limit out in front of this thing. Okay, so we got 9 times 3. Then we're going to do 9 times h. So plus 9h. Then we'll do, I should have made this 6h. So before I do this, let's not make way more terms than I should. This is 6h. So let's just work from that. So this is going to be 6h times 3. So plus 18h. Then 6h times h would be plus 6h squared. Then we are going to do, color I haven't used yet. Then we're going to do the h term. So h squared plus 3, 3h, h squared times h, oops, I forgot a squared here, h cubed. And then you have the minus 27. And all of that is divided by h. Okay, so we have the limit, h approaches 0. Okay, so now we're going to combine like terms. First off, notice that this 27 out front and this minus 27 are going to cancel. So let's get rid of those. Make our lives easier. Then we have 9h will combine with 18h and become 27h. Okay, that's the h's. Then 6h squared will combine with 3h squared and become 9h squared. And then the only other term is h cubed. So plus h cubed. All divided by h. Now because every single term has at least one h in it, you can cancel this h and one of these h's and one of these h's, and you get the limit h goes to 0 of 27 plus 9h plus h squared. Then when we set h to 0, so now we're going to plug this in, those two terms are going to go away. So the answer is just 27. Oh, I was looking at the wrong one. Up here, there we go. So that's the answer for that one. Okay, kind of a lot, but hopefully it won't be too bad now that I've shown you one. Okay, for problem 7, it's this one would be really challenging if I didn't show you how to do it. So you have to get rid of the square root. And to get rid of the square root, you're going to multiply by something called the conjugate. Oops, I wish I would write a little nicer. Okay, 4 plus h. And if that's minus 2, you're going to write plus 2. But I can only do that if I also multiply the bottom by square root of 4 plus h plus 2. Now those two terms are exactly the same, so they're really 1 because I'm dividing something by itself. So I'm really just multiplying this fraction by 1, so there's nothing wrong with that. Okay, but now we got a FOIL. So the first and the first would be square root 4 plus h, square root 4 plus h. All that's going to do is remove the square root, so it becomes 4 plus h. Then the middle, so FOIL, first outer is going to be 4 square root of 4 plus h plus 2. So it's plus 2 square root 4 plus h. Then the inner is going to be minus 2 times the square root of 4 plus h. Now multiplying by the conjugate always produces this result. The middle two terms will cancel. Then the last two terms are minus 2 times positive 2, which is minus 4. So that's the top, and it's still the limit. I keep forgetting to write that. The limit as h goes to 0. Then the bottom, we have two terms, h times this one and h times this one, so we're going to get, actually let's not even write it. I think the way we want to write this is just h times the quantity 4 plus h plus 2. So don't even distribute that h. Forget I wrote that. You'll see why in a second. Okay, now positive 4 minus 4. 4's will cancel. Plus 2 root 4 plus h minus 2 root 4 plus h. Those cancel. All you're left with on top is h. So the top, so this is the limit as h goes to 0 of h divided by h times the quantity square root of 4 plus h plus 2. Now why am I doing this? I should have pointed that out. I have to do algebra until I get to a state where I can plug in the numbers. So I cannot plug in h equals 0 because I'm going to get a divide by 0. In fact, every step up until what I'm about to do, if I plug in h, I would get 0 on the bottom. But now at this step I can see there's one h on top, one h on bottom. They will cancel. Now a lot of students forget this. They want to say that there's nothing on top. There is 1 on top, so there's one h. So if I cancel the h, there's still a 1 there. So what happens is we get the limit as h approaches 0 of 1 divided by the square root of 4 plus h plus 2. And now I can plug in h of 0 because it will not force this function to be divided by 0. So make that h a 0. You get 1 over the square root of 4 plus 2. Square root of 4 is 2, so this is just 1 over 2 plus 2, which is 1 over 4. Okay, so that's multiplying by the conjugate to allow us to get a function where the h can be removed from the denominator. Okay, in problem 8 they want us to graph this, so I'm going to go to Desmos. They want us to graph x squared cosine 18 pi x and then minus x squared and positive x squared. So let's see if we can get this. So they want minus x raised to the second. They want x raised to the second times cosine of 18 times pi times x. And then they want negative, we already got that one. They want positive x raised to the second. So we have 3 graphs here. Let me make sure we got that right. So we had x squared times cosine 18 pi x. X squared cosine 18 pi x. That looks right. Okay, and they want the limit as x approaches 0. So if you notice that cosine term, the blue one, the x squared cosine 18x, is bounded by the green curve, which is positive x squared, and the red curve, which is negative x squared. So this is called squeeze theorem. The idea is if my function is in between two functions and those and they're converging on something, then the other function has to converge on that. So both the green and the red are both approaching 0 in the y as x approaches 0. Therefore, the blue one, since it's in between these two functions, also gets squeezed down and has to also approach 0. So the way you would say that is cosine, just cosine without the 18 will always be bound by minus 1 and 1. From trig, hopefully you remember that. So cosine without the 18 in front will always be bound by minus 1 and 1. And then if we add the x squared into it, so that has to be less than regular x squared, because the biggest that this cosine can ever be is 1, so at most it would be equal to the x squared, negative x squared. That was f of x. And at most it will be smaller than positive x squared. So this line just says that this x squared cosine 18x, the blue one, is in between red and green. Okay, and then since those two both have limits approaching 0, then so does the middle function by the squeeze theorem. So everything's going, this one, again, I'm not psyched about these numbers. the x is going to 0, but the y is also going to 0. And it's the y value that we're interested in. That's what the limit is the y value is approaching what? Okay, so that's problem 8. Hopefully the graph helped. Okay, for problem 9, we just have to plug in the value. So it says we've got 6x and we've got this polynomial over here, and we're seeing as g of x approaches 1. So if g of x is being squeezed by these two functions, we just have to plug 1 into the functions and see what g of x should be. So this is going to be 6, 1 has to be smaller than or equal to the limit as x approaches 1 of g of x has to be less than or equal to, it's 3 times 1 to the 4th minus 3 times 1 squared plus 6. 6 times 1 is 6. This is the limit as x approaches 1 of g of x. And then this is just 3 times 1, which is 3, and this is 3 times 1, which is 3, and it's 3 minus 3, so this just becomes 6 as well. So this is basically saying g of x has to be sandwiched between 6 and 6, so it has to also equal 6. So that limit has to be 6 because it's being squeezed between those two numbers. Okay, for problem 10, it says find the limit if it exists, if an answer does not exist, enter does not exist. So for these, we have to do two problems. So when they have absolute value like that, we have to set up two statements. X approaches -7 of, notice the top factors into 2x plus 7. In the bottom, we're going to leave as x plus 7. So the x plus 7s will cancel. I should record, don't let x equal -7. You don't need that for this problem, but it's a good habit to get into. And if these collapse, then you get 2. But then, because of the absolute value, you have to set up a second equation that says this. 2x plus 7 divided by -x plus 7. Because if this x plus 7 was negative, then it would become positive, I'd get the same answer. So you have to set up one where this is positive and one where this is negative, and then analyze it. So again, this is going to cancel, but you're going to have a -1 in the denominator, so this is going to equal -2. Now these are not the same. So because those limits don't approach the same number, we're going to say the overall limit does not exist. Okay, so that's 10. Okay, for problem 11, it's the same kind of approach. We have the limit as x approaches -4 of 4 minus x over 4 plus x. And to handle this one, we're going to have to, so in this one, you can't actually simplify this at all. So if that was a plus, they would cancel and it'd be nice. But these don't simplify, so you can't plug in -4. So if you plug in -4, you get 0 in the denominator, and so we have a problem. So we can't do this one. So then we try the other one. X approaches -4 of 4 minus x, so make the absolute value negative, 4 plus x, and we would get this equals the limit x approaches -4, 4 plus x over 4 plus x. Those both cancel and the whole thing is just 1. So this is the limit as x approaches -4 of 1. And the limit, I should have put this, this is a limit law. If you have the limit as x approaches a of any constant c, the answer is just c. So basically it means it's independent. It doesn't matter what your x does, the y value is always c. So in this case our constant's 1, so this whole thing is just 1. And that's what we get. Okay, problem 12. we've got what's called a piecewise function. So it says, this is called the sine function. X equals -1 if x is negative, it's 0 if x is 0, and it's 1 if x is positive. So the correct graph for that is this one right here. So it's a constant -1 if x is negative. At 0, you get a dot at 0, and then if x is positive, you have a hole and then positive values. So that's the picture, and then from that, hopefully we can answer the questions. So it says, what's the limit of this sine function as x approaches 0 from the right? So remember, this plus sign means I'm approaching 0 from the right. Well, that's approaching +1. Then it says, what is it approaching as I go from 0 to from the left? So from the left side to the right side, it's approaching -1. Now, because these are different, the limit of the sine function as x approaches 0 from both sides does not exist. So those are different numbers, so I'm not approaching the same thing. There's a gap there, so the limit overall does not exist. Okay, what's the limit as x approaches 0 of the absolute value of the sine function? So this one's interesting. The absolute value of the sine function would, in essence, make all these this -1 +1. So now for negative x values, we have this line. So this absolute value right here is going to flip this up to here. And now the limit from both sides, it's approaching the same value, which is that 1. So that one does work. So the absolute value is just going to make all negative values positive, and so now we have one line, although there would still be that hole. So there's still a hole at 0, and it's filled in with a y value of 0. Okay, that's problem 12. Okay, for problem 13, it's another piecewise function. Now, I think it's helpful to look at the picture of the answer for the sketch first, so then we can fill in the other answers graphically. It's a little easier to track it. So it says, what's the limit as x approaches 1 from the left of g of x? So here's 1. Where is this going as I approach from the left? It's approaching +1. So it's approaching 1 in the x, and it's approaching 1 in the y. What's it approaching as? What is g of x doing as x approaches 1 from the right? From the right side, it's coming from down here, and it's also approaching 1. Now it says, what is g of 1? G of 1 says, what is the actual y value when x is 1? Well, it's this dot right here, which is 4 units up. So the answer is 4. Okay, now it wants us to look at approaching a different value. It says approach 2 from the left. So 2 is right here. From the left, this is approaching -2. What's it doing from the right? From the right, it's coming down like this, and it's approaching 0. And because these two are different, the overall limit of x as it approaches 2 from either side does not exist. So those have to line up. If you have any kind of gap, it's not going to exist. Okay, so that's 13. Okay, for problem 14, they give us this example. So you have to click on this link here, and it brings up this what's called a step function. And I did a snippet so we could have it on the screen at the same time as the question. And it says, what's the limit as x approaches -2 from the right? So it's kind of hard to see. -2 would be over here. And if you're approaching from the right, you're on this line, which is at -2. So the answer is -2. Then it says, what happens if you're approaching -2 from, this has no direction, so from either side? Well, it's hard to see. Let me see if I can fill it in. There's another line that looks like this. And that's at -3. So from the right, I'm approaching -2, but from the left, to stay on this line, I'm approaching -3. So in the step function, I'm approaching, again, two different things, so there's a gap, so I can't approach 2, it would be does not exist. Okay, now it says approach negative 2.2. Well, negative 2.2 would be, boy, this is going to be hard to do. Negative 2.2 would be this green dot, let's say right about there. Now from the left, I'm on this line, and I'm approaching this 2.2, and I'm on the -2 height line. And from the right, I would approach on the -2 height line. So in this one, so this was negative 2.2. But they're on the same line now, and they are going to be, oh shoot, I drew it the wrong spot. It's actually down here. Should have been down here. I drew like negative 1.2, not 2.2. So negative 2.2 is down here, but the same argument holds. From the left, you're on this line. From the right, you're on this line, and it's actually approaching -3. They're both on the -3 line. So it'd be -3 is the limit. Okay, so if you use that as an example, we can see that if you approach things from the left, you're actually on a number lower than that number. So let's just try to bring that home. So this is -2, this is -1. If I approach -2 from the left, I'm actually on the -3 line. If I approach -1 from the left, I'm actually on the -2 line. If I approach 0 from the left, I'm actually on the -1 line. So the number I'm approaching is always, my y value is actually 1 below that. So I approach -2, my answer is -3. I approach -1, my answer is -2. So the answer would be your number -1. If I approach from the right side, it's actually the opposite. So let's go up here. If I'm approaching 1 from the right, I'm on the 1 line. If I'm approaching 2 from the right, I'm on the 2 line. If I'm approaching 3 from the right, I'm on the 3 line. So in those cases, from the right side, I am on the same number. So whatever number I'm approaching, I'm on that number. So we can see that. From the right, I was approaching -2. The answer is -2. From the, no, I guess I didn't have one from the left. I just showed it on my own. So if you're coming from the left, you're actually going to be at the -3 line. Okay, so now what does it say? For what values of a does the limit x approach a exist? So it's only going to exist if you have a non-integer value. So you have to be somewhere on one in between these lines. So I can't be at 3 or 4 or 5, because at 3 or 4 or 5 it switches. It jumps from one step to the next step. That's why they call it a step function. But if I'm anywhere in between, so if I'm at 4.2 or 4.5, or I'm at 3.4 or 2.7, those will all have limits that exist because I can actually approach from left or right and be on the exact same line. Okay, a lot to think about there. Step function can take a little bit of thinking. It is common though, so anytime you go to a place where they charge based on increments of something, like it jumps, the price will jump based on some quantity, that's using a step function. Okay, problem 15 might be one of the hardest ones in here, so let's really look at it. It says, what's the limit as x approaches -2 of 3x squared plus ax plus 8a plus 6 divided by x squared plus x minus 2? So the first thing you want to do, -2, is factor and how did I do this? Yeah, I think I wrote this like this. And then you divide by factor x squared plus x minus 2. It's pretty easy to factor. It's x plus 2, x minus 1. So in essence, what we want is we want a to create a polynomial on top that I can divide it by x plus 2. or it factors into some bubble that has x plus 2 and then something else, so that this x plus 2 cancels. I have to cancel that, and let's write this. We want to cancel x plus 2. The only way I can do that is if I have a polynomial on top that includes the bubble x plus 2. So here's how you do it. You write 3x squared plus ax plus a plus 6, and you long divide that by x plus 2. So basically, in essence, we're saying I want this to be divisible by x plus 2. So let's review long division. So you start with x and you say, how many times does that go into 3x squared? Well, it goes in 3x times. And now you multiply down into x and get 3x squared, and into 2 and you get plus 6x. And then you subtract. 3x squared minus 3x squared will be 0. Ax minus 6x will be a minus 6, and they both have an x on them. So you can factor out an x. So you get ax minus 6x, and you can factor out a common x, and you get a minus 6 times x. Now you ask, how many times does x go into a minus 6x? Well, it goes in exactly a minus 6 times. So if I multiply a minus 6 times x, I get a minus 6 times x. And now you repeat the process. You say take this times x, and you get a minus 6x. Then you take minus 6 times 2, and you get minus 12. And I should have written this term will drop down, so you get plus a plus 6. And then long division says subtract these two things. So we're going to get a minus 6x minus a minus 6x. Those are this exact same term, so they're going to cancel. And we're going to get a plus 6 minus minus 12, which is plus 12. Okay, so now the only way that this factors correctly is if this remainder equals 0. So we have to have all of this equal 0. And this is a plus 18. So a has to equal negative 18. And did I miss something here? I have it as equaling positive 18. You got it right there. Let me look at this quick. Okay, I see the mistake I made. Hopefully you can see it too. This is not 12. I just did 6 times 2. It's not 12. It's the whole term. So all this is going to change. Actually kind of amazed that it turned out to be 18 when I totally forgot a whole term here. So what it should have been is the entire bubble a minus 6 times 2 would be plus 2 a minus 6. There we go. Okay, now let's apply this. So now we subtract, this whole thing goes away, and we get a plus 6 minus 2a plus 6. Let me write that. We get a plus 6 minus, this minus will distribute to that 2, a minus 6. And this whole thing has to equal 0. So that remainder has to be 0 for this to balance. So we get a plus 6 minus 2a plus 12 equals 0. This a and this minus 2a will be minus a. This is 6 plus 12 is 18. And subtract 18 from both sides, and we'll get minus a equals minus 18. Divide both sides by minus 1, we get a is 18. So we get the a value for which that should be balanced. So let's actually see that. So back here, this is going to give us what this factors into if it has 18 in it. So let's write this. It's going to be 3x plus 18 minus 6, which is 3x plus 12. So that is one of the bubbles, and the other bubble is x plus 2. Now I'm not going to go through this, if you were to FOIL that, you will get the top if you substitute a as 18. And we had the bottom, so now we're kind of looking back at this whole thing. We have the bottom as x plus 2, x minus 1. And this whole thing is the limit as x approaches negative 2. Well, now and only now we can cancel, and we're left with the limit as x approaches minus 2 of 3x plus 12 over x minus 1. But now you can substitute in this minus 2 for these x's, and the limit goes away when you do that. 3 times minus 2 plus 12 over minus 2 minus 1. This is minus 6 plus 12, so it's 6 on top, minus 3 on bottom, simplifies to minus 2. So I told you it was probably the hardest problem in here, and you see why. So long division, solve for a, back substitute, factor, cancel, substitute in your x value, and you'll get the limit. Okay, these last ones are true false, so we can go kind of a little quicker with these. So it says we've got the limit of two functions being divided, and one of them is 3 and one of them is 0, and it happens to be that the 3 is on top and the 0 is on bottom, so this does not exist, which is what they said. That's true. Okay, in problem 17 it says we've got f of x approaches 0 as x approaches 8, g of x approaches 0 as x approaches 8, then the limit does not exist of those two being divided. So this actually would be 0 over 0, and this is actually a special case. So if you have a number over 0, it does not exist, but if you have 0 over 0, this can actually work. This can work. And I'm not going to show you what we do. We do something called L'Hopital's rule. But you can change the function until you don't get 0 on the bottom. So this one is false. So they say it does not exist. I will teach you later in the course methods where we can make it work. So this one's false. Okay, determine whether the statement is true or false. If p is a polynomial, then the limit x approaches b, p of x equals p of b. So the only time limits break down are when you have square root of negative numbers or you have divide by 0. A polynomial by definition never has those things. It never has square roots and it never has divide by 0. So a polynomial is just some number, x to the n, plus some different number, x to the n minus 1. And this pattern will continue until you get a1, x1, and a0. So basically it's just a bunch of combinations of x's to powers and numbers. You'll never get a divide by 0 out of that, and you'll never get a square root of a negative number. So all you have to do is plug in the value. So whatever this b value is, just plug it into the polynomial, and you will get the answer that it requires. So that is problem 18. Okay, problem 19, it says, determine whether the statement is true or false. I have f of x is going to infinity, g of x is going to infinity, then the limit is infinity. Okay, so this is where we get into discussions of infinity, which are always interesting. So basically they're saying this one's going to infinity, this one's going to infinity. Well, that's the same thing. So the same thing minus itself equals 0. Not true for infinity. So it actually depends which one goes faster. So one might be going to infinity much faster, and so it will dominate. The other one might be going to infinity much slower. So basically you have to do an analysis of, how fast these things are going to infinity, and then you can actually get a value from this. So that one's false. Okay, last problem. Determine whether the statement is true. If f of x is bigger than 5 for all x, then the limit as x approaches 0 of f of x exists, then the limit of x approaches 0 of f of x is greater than 5. So this one is also not necessarily true. So I wish I had a drawing that we could look at for this. But basically, you could have a situation where the limit itself is not bigger than 5. So this one was false. Okay, and that will complete section 2.3.